Okay, I wanted to do the next problem on your scatter plot introduction. This is really going to be slides 15 and 16. Okay, we've looked at scatter plots. We've looked at line of best fits. Okay, now we're going to find the equation of a line of best fit and use it to make predictions. Okay, so this is really slide 15, and we'll do the problem on slide 16 along with it. Okay, so we have test scores along with hours studied. So apparently, they asked some students how many hours they studied and their test score, and each of those students have a point to represent that. Okay, we have a line of best fit drawn. Okay, we want to have about the same number of points above the line as below the line. Okay, that looks pretty good. Okay, we're going to first find the equation of the line. Okay, when we find the equation of the line, okay, we're ignoring the dots now. Okay, we use the dots, the red dots, to come up with the blue line, okay? But now ignore the red dots. Okay, so to find the equation, we could find the y-intercept first. Okay, the y-intercept is where the graph crosses the y-axis. Here's the y-axis. Let's see, here's 60, here's 80, there's 70. Okay, so this must be 65 right there. I'm going to guess that the y-intercept will be about 61. Okay, this is just an approximation. Okay, to find the slope, and again, ignore the red dots. I'm going to try to find two corner points. And as best you can. Sometimes you can't find corner points, but we try to do the best we can. This point on the line that the yellow arrow is pointed to is pretty darn close to being on a corner. And so is this point right there. Okay, so I'm just going to think about rise over run. Okay, you could use the coordinates. You could find out what the coordinates of those 2 points are. But I'm just going to use rise over run. Okay, to get from here to here, maybe I should use a different color so you won't get mixed up with the original dots, brown. Okay, to get from there to there, we're going to go up and over. Okay, we're going to go up one space, but one space on this particular y-axis is really only a test score of 5, a difference of 5 points in your test score. Okay, so the rise would be 5 points, okay, 5 points. And then the run would be over 2 spaces. But on this particular graph, 2 spaces is only half of an hour. Okay, half of an hour. And I want to keep this in terms of score per hour. Okay, score points per hour. So I'm going to write it as a half of an hour. So 5 points for every half hour. Okay, I could simplify that. 5 divided by a half is really 5 times 2 over 1 if you copy, change, flip. So it's 10 points an hour. So apparently, in general, the students, if you spend an extra hour studying, that's an extra 10 points on your test. Okay, so the slope is going to be 10. Okay, the equation then, y equals slope x plus y-intercept. So y equals 10x plus 61. Okay, you remember that? The slope goes in front of the x, and the y-intercept goes after the plus. Okay, there's our line. Okay, so on the next screen, it says predict the test score for 1 hour of studying and 2.5 hours of studying. Okay, one thing you could do is you could actually just use the picture of the graph. Okay, you could look at this 1 hour of studying, and you could go straight up to this graph, and try to eyeball where that line is. Okay, I don't know, maybe 72, because it'd be right across from about 72. And then for 2.5, you could go straight up and look at the graph, the blue line, go straight over. It looks like it'd be about a 90. Okay, from the graph. Okay, there's nothing wrong with that. But I also want you to know how to use the equation. So let's see, I'll put it up here. So this is on your next slide. Predict the test score for 1 hour of studying based on this data. Okay, so if it's 1, you're going to take the equation, and you're basically just going to replace x, because x is hours, and that's what they're giving you. They're giving you 1 hour. Okay, you're going to take that x value of 1 and put it in for x. So we get y equals 10 times 1 plus 61. Okay, because y is the test score. Okay, that's what we're trying to find. So that variable is still there. And they gave us 1 hour, which was the x value. So all we have to do is take 10 times 1, add 61. 10 times 1 is 10, plus 61 is 71. Okay, so 71 is a good prediction for 1 hour of studying. I think we said 71 or 72 when we looked at the graph. Okay, 2.5 would be the same way. If they want you to predict for 2.5 hours what the test score would be, okay, again, you could look at the graph, or you could take y equals 10 times 2.5 plus 61. Okay, 10 times 2.5 first, multiply before you add. Okay, 25 plus 61. Let's see, 5 plus 1 is 6. 6 plus 2 is 8, about an 86. Okay, so this prediction based on your equation for 1 hour of studying would be a grade of 71. And 2.5 hours of studying would be a grade of 86 based on the equation. Okay, just briefly, when you do the line of best fit, first of all, the line of best fit may be a little bit different for every single one of you to do it, right? Okay, it's an approximation. And even when you have a line of best fit, there could be a little bit of leeway with the slope and the Y-intercept based on your corner points. Okay, so this is all approximations. We just try to get a good guess, a good approximation for the questions they're going to ask. Okay, let me know if you have questions. I'll do one more problem with you, and then just keep me posted.